Welcome everyone to the PASS Virtual Summit 2020. My name is James Serra, and the session today is Azure Synapse Analytics, a data lakehouse. A little bit about me. My name is James Serra. I'm a data and AI architect at Microsoft, and I've been here 6 years. There is my email. If you have any follow-up questions afterwards, feel free to reach out to me. A lot of things I've talked about today are on my blog, so if you'd like to go there for more information, please do so. A couple of things about the PASS Summit. There's a lot in addition to this summit, part of the PASS organization on there. They're always looking for a lot of volunteers. They have a lot of virtual groups. They're looking for speakers. I speak at a lot of these virtual groups. I speak at a lot of SQL Saturdays, so make sure to check them out if you're not aware of them. Your feedback is very important. So after the session, please go out and fill out an evaluation. Constructive criticism is always appreciated. So please make sure you get a chance to do that afterwards and spend a few minutes on that. Couple other things about me if you wish to contact me. There's my LinkedIn and Twitter feed on there. I have been a SQL Server MVP at one time before I joined Microsoft. I've been at Microsoft 6 years. Been in the industry for 35 years, and part of that was a DBA for many years. So I try to bring some of that experience into my presentations. The agenda for today, I'll give you an introduction on Synapse. I'll talk a little bit about massively parallel processing, MPP, which is part of Synapse that makes it unique to other systems like SQL Server. And then most of this presentation will cover a Synapse demo where I'll go through a lot of the features. When we look at Synapse at a high level, the idea is we're going to take big data, traditionally in a data lake, and the data is landed in there as schema on read, meaning I can put data in there without doing any upfront work. It allows me to experiment with that data, explore that data, compared to a relational database, your data warehouse, a SQL server, where a lot of times there's operational data in there that's been imported. It provides a lot of security, it's dependable, and in the past, these have been two different systems on there with different technologies that were used to grab the data and query it inside of there. Where Synapse tries to do is bring these two worlds together, create what's called a data lakehouse, which is a merging of the data lake and a relational data warehouse on there. So hence the term data lakehouse on there. So we'll see how these two are meshed together frequently in this demo. If we look at the traditional data warehouse, it's been a combination of tools. We're ingesting all this data. We're usually using Azure Data Factory. We're preparing this data, enriching this data. We could use Azure Data Factory. We can use Databricks, among other tools on there. And then we serve this data or model this data in a relational database like SQL Data Warehouse. And then to store it, we use in data lake storage, and to visualize it using Power BI. Well, the issue is this is a lot of pieces, a lot of moving parts. I have to jump out to various tabs and create different workspaces to jump all over the place on there. So what we try to do with Synapse Analytics is have one place where you have a single pane of glass where you can do all this work and not have to jump out to separate workspaces and use separate tools and such. So it'll really become clear in the demo that I'm giving. And also to clear up some confusion, what we have now out in GA, generally available, is Synapse Analytics, which was formerly called SQL Data Warehouse. So this is no different. It was simply a renaming of it. Now that product has a lot of features you can see that have been added recently. Other ones in preview, they all go into this GA version. And if you go to the portal in Azure and type in Synapse Analytics, you'll see it here where it says formerly SQL Data Warehouse. That's the GA version. And public preview that you also see here is where it's called Workspaces Preview, is all these additional features. So these features that are in the SQL Data Warehouse, this is still available within Synapse under what's called the SQL pool. And as new features go into the GA version, they go into the preview version, but the preview version gives you a bunch of other options. And that'll be the focus on the demo today. and you'll see a lot of other features that you won't see in the GA version. Looking at a high level, what's underneath the covers of Synapse? First of all, you have these workspaces. So this is sort of a bucket or a label of collection of all these resources that are on the right-hand side of this. Typically, customers will create workspaces by project, or maybe they'll have a dev test and prod one, or maybe they'll broken up by organizations on here. But each of these workspaces is where you'll configure all these different resources. Overriding all of this is Azure Synapse Studio. So this is a new product. That's that single pane of glass that's used to access all the resources. Those resources include some ingestion pieces. Azure Data Factory pipelines and mapping data flows are the ingestion piece inside of Synapse Studio. We don't call it Data Factory, but it's the same code base underneath the covers on that. When you ingest data, then you got to land it someplace. And so this is where we have this relational database. This is your traditional data warehouse that's in the GA version, tied to those provision pools or SQL pools, as I mentioned before. So that's the same. And you use T-SQL to query that data. You also have Data Lake Store Gen 2 in there. This is your data lake. So you'll create this storage outside of Synapse Studio, and then you will link to it inside your workspace, and then it will become part of your workspace. This data can be queried with a new feature called SQL On-Demand Pools. This is what I'll focus a lot on today because this is really amazing and awesome feature. And this allows you to use regular T-SQL over data sitting in the data lake, something that we didn't have before. And even better, you're only paying when you run the query. So what this means is I can go to Power BI and I can attach to a SQL on-demand pool, and that could run a T-SQL that's going right against the data lake on there. So I'm saving time by not having to move it to relational database, and I'm not having to pre-provision a relational pool. So I'm saving great costs while also getting access to the data quicker. We also have a new feature in here, Spark tables. So there's an Apache Spark Pool version in Synapse that allows you to create notebooks. In those notebooks, you can create Spark tables on there. So for those of you using Databricks, this is an option to use instead of Databricks inside of Synapse, where you have all these Spark notebooks available to you in many different languages that can access the data, whether the data is sitting in a Spark table or Gen 2 data lake store or relational database. And we also have a link to Cosmos DB. So this is this new feature that came out last month called Synapse Link to Cosmos DB. So I can use on-demand pools to query data sitting in Cosmos DB. So if you look at this, I can now take Power BI and I can run a query that's going to go against data sitting in the data lake and data in Spark tables and data in Cosmos DB, all using T-SQL. And this will be the ending of my demo where I go and show how you can link all three of those together in one select statement. So it's a pretty amazing feature. So this opens a new way of thinking of a modern data warehouse now. So while we still have the same steps along the way, the 5 listed here, each of them now has a lot more options on there. So if I look at the ingest, I can continue to use Data Factory pipelines to explore, meaning just to see what's inside some of these files that are sitting in the data lake. I have Spark and pipelines as usual, but I also now have the serverless. And you'll see in the demo how easy it is now to explore data sitting in the data lake. To transform, enrich, clean the data, I now have a bunch of different options on here that we'll go through. And then I still have the option to model that. So there's still plenty of use cases where you want to continue to copy that data into a relational database and then use Power BI on top of that. Overriding all of this is Data Lake Store Gen 2. But now you have a lot of options. So it does add complexity because there's more options to choose from. But as you'll see, I'll cover most of these options. It'll make it a lot easier for you to build solutions. And also there's a big cost savings involved in this. A big reason for cost savings in this new public preview of Synapse is the SQL serverless. And I should point out that these This is a renaming, so we have it called SQL On Demand, but it's going to be renamed soon to SQL Serverless prior to the time you view this. And the SQL Serverless has the ability to use T-SQL. It has to go against numerous data sources, and it's a pay-per-query on there. It also has a feature to auto scale on there, and when you're not using it, you're not paying for it. It also has a really cool feature that's listed here, where if I use my Spark pool and with that Spark pool, create a Spark table on there, the metadata from that Spark table will be copied over into Synapse, the on-query service on there. And that can then go and access that Spark table, which is sitting in Azure storage. So what that means is while I use a Spark notebook and create a Spark table, I can avoid using that Spark pool, and go and use the Synapse T-SQL to query that same data without having to use the Spark pool. So it's a really awesome feature in there that allows you to again easily pull that data using T-SQL while saving a lot of cost by not having to fire up a Spark cluster. So I like to think of the SQL on demand or SQL Server now having three scenarios that are playing out a lot with customers. One is basic data exploration. This means I can go in and quickly see what files have landed into my data lake without having to do a lot of work on that. And it's made easier by automatic schema inference, meaning when I query it, it'll automatically pull the data out, the metadata inside that file, say a Parquet file, and pull it out and show it as part of the headings on there. So you'll see how easy that is within a demo. So just a basic way to go and find out what's sitting in the data lake is a big option of serverless. And I can do that through queries, or I can go into Power BI and do that. Also think of it as giving the ability to have a logical data warehouse or a federated query that I can go and query this data as it sits without having to move it into one central area. So as I talked about before, you can have data in a data lake and Cosmos DB and Spark table in there, and I can query off of those without having to pull it into the relational database on there. So you're creating this virtual SQL layer on there. Down the road, there'll be even more sources that you can use. But for right now, it could be a big benefit of there and save you a lot of time of building out a solution. And then finally, we have data transformation. So this is an interesting way for customers who really like T-SQL, maybe have written a bunch of stored procedures that are cleaning and transforming of data. They can continue using that because of the T-SQL support against data sitting in the data lake. So instead of having to use another product like a data factory or a Databricks to clean this data, and maybe you don't want to use those other products because you're much more familiar with T-SQL, you can continue using T-SQL to go and query that data that sits in the data lake, clean it, and then write it back out to the data lake or to the Synapse relational database on there. So you continue using the T-SQL as well as saving costs in there because you just run it per query on there. So there's no pre-provisioning anything. So a lot of flexibility while having cost saving at the same time. So massive parallel processing. I wanted to talk about this feature, which is part of the SQL provision pools on there. So what was formerly SQL Data Warehouse. So a lot of customers are not aware of how this differentiates between an SMP solution. Your typical SQL server has the ability to scale up, and that's fine, but at some point you may run into a limit where you just can't get the performance you need because you're running out of memory and disk. And if you're on-prem, you have a SAN and network controllers on there. So what you have to do then is get more hardware, which is a real pain. I've done that many times as a DBA. So you back up the database, move it to this new set of hardware that you provisioned, and then repoint everybody over there after you restore it, move all the security on that. But then at some point you're going to run out of you're going to run to a ceiling. You can't do anything more with the scale up on there. And this is where the MPP technology comes in, this massive parallel processing. Its ability to scale out. And I'll have a slide next that'll show you how this works in more detail. But I can add CPU and memory and disk and have essentially an unlimited way to scale this out and get more processing power on there without having to do any new provisioning of hardware on this. So you just say, I need some more power, CPU power on there, and you automatically get it without having to do anything, which is in a couple of minutes on there. There's also a way within massive parallel processing technology within Synapse to dedicate resources to individual queries on there, which has always been a challenge at SMP, where you can have one query that can sort of overwhelm the whole system. With the massive parallel processing, as you'll see in there, you can dedicate the resources, and so everybody's sort of in their own lane, and they cannot override everybody else and interfere with those other queries that are being run. Well, how does this work? So we have a control node, and this is the face of Synapse to all the end users. Behind that is various compute nodes that you can fire up. So you can scale out to get as many different compute nodes. And then there's also storage. So the data is laid out over this balanced storage, which I'll talk about in a minute on there. So the idea is the public facing is this control node, and this is sort of the brains of Synapse, but doing the work is all the compute. And underlying that is this DMS technology, data movement services, and this is what is added on top of the regular SMP solutions to allow it to be scalable and be an MPP solution. So how does this work? If an end user submits a query, it goes right to the control node. The control node then uses a query plan, but it's a parallel query plan. So it's got more to it than a regular query plan in SQL Server. And what that query plan does is this breaks up that query into smaller queries. And each of those are fed to a compute node. Each of those compute nodes runs that query locally against its storage on there, filters that query, returns just the result into the control node, which mashes it up and sends it back to the end user on there. So the more you scale out, the quicker it's going to be. So a great analogy a customer once gave to me was, if I have a deck of cards and there's 52 cards and I'm looking for the king of diamonds, and I can flip through that, but it may take some time. Well, I can scale myself up. I can make myself faster, but it still may take a time to get to that king of diamonds. However, if I instead take those 26 cards and split it out to 2 cards each and give it to 26 people and tell them to overturn the cards, it's going to be much quicker on there. So that's what the scale out technology gives you. Much, much faster processing. Anywhere from 20 to 100 times faster queries will run under this technology. So the big difference is how this data is laid out. And most data warehouses use this star schema where you have one large table, a fact table, then many smaller tables, dimension tables, which are almost always joined together. So what we do underneath the covers with Synapse is you have the ability to choose how that data is spread over all the storage. So I can replicate that, and that's usually, as one option, that's usually done for the dimension tables because they're smaller and data's storage is cheap. I can replicate that over into all the different storage areas. However, the fact table is something that I'm going to break up into smaller pieces because it could be really large on there. I'm going to break it up based on a hash or a round robin, and I'll talk about those later, that are ways to get the proper skew so the data is balanced evenly among all of those. So this helps out because frequently that when that fact table is joined to the dimension table, I can do that all locally in this compute node because the data that the fact table is joining with is the dimension table, which is all there because it's replicated. If it wasn't replicated, pieces of it would be all over in these different storage areas, and we'd have to do what's called shuffling and move all the data around to get it to join. So we save a lot of time by not having to do that shuffling, by just replicating the data. So I usually spend half a day, maybe a day with DBAs to go and make them understand the differences in laying out the data so they understand the way to get most out of it and the query plans, how they differentiate between SMP versions. What's the difference when you need to lay this out? Is it difficult? No. What you'll do in your create tables, you'll just have one extra property on there called distribution, where you specify either it's a hash or round robin or replicate it on there. Once you hit execute for this create tables command. It goes to the control node, keeps the metadata on that control node because that control node doesn't have any data on there. So what it does is it push down a create table to all the compute nodes, and each of those compute nodes then distributes part of that large fact table into its own storage on there. And you can continue using other features like partitioning to get even more speed out of it. Now, most customers don't need to bother with partitioning because it's fast enough, but you can squeeze out more performance by doing partitioning. Underneath the covers, the data warehouse Synapse uses a concept called DWU, data warehouse units. And this is an easy way to give a SQL pool more CPU, RAM, and IO. It's just literally a sliding button on here. So if I start this out at say DW100 and I slide it to 200, it's going to give me twice as much performance. It's pretty linear on how that works, and so that process usually takes about a minute, and there's only a brief interruption of connections when it's completed on there. So it's an amazingly easy way to scale up and down. And you could set this to run on the schedule to scale up and down. You could do it manually. And coming in the future is a way to auto scale and auto pause. Right now, we don't have those, but we do have also a way to manually pause this. So you can use that as a way for cost savings. The way the architecture works, going deeper behind the scenes, is there's 60 distributions pre-allocated in Azure Blob Storage on there. And that's fixed. So whenever you say, I want to distribute a fact table, it'll distribute it among these 60 partitions. And the good thing is that means if you scale up or down, you don't have to move data into additional partitions because we keep it fixed at 60. Now, the compute is what changes. So if you start up at DD100, you're going to have essentially one compute engine or worker node on there, which behind the scenes is just a VM. And as you scale up, what happens is you get additional workers. So if I go to 600, I'm going to get 6 workers. And if I scale all the way up, I'm going to get a worker, 60 of them per storage on there. So it'll be a one-to-one relationship. Now that can change, and we don't go into details in our documentation on this because the idea is we want to make it simple for you. You need to understand all this. You don't need to have specify the number of vCores you're using it and how much IO you're using and all that. It's just that sliding scale. So it makes it much easier to start this up, and it makes it very easy to scale. All right, with that, I would like to go into the demo. All right, the first thing I want to do is when I go to the Azure portal is if I type in Synapse, you'll see I have this former SQL Data Warehouse and the workspace preview. So we're going to work on that workspace preview. And so you can see here I set up some workspaces previously on here. So there's not much to setting up the workspace on there. If you go in there, you see then a resource group, the name and the region, and then the data lake stored Gen 2. So a lot of the metadata, think about it, of the workspace is going to be stored in Gen 2, so you need to specify an account there. And that's really it, and it'll just take a couple minutes for that to get set up. Once that's done, you can jump into the workspace. So if I look at this, you'll see on the overview page, I have a bunch of information. We'll talk about some of this later. And the two things you're usually going to do to start out with is if you look at this new SQL pool and Apache Spark pool, also here on the left-hand side, you can see them too. So if I go into click one of these, the SQL pool, you'll see this has got the on-demand. So by default, you have an on-demand already up and running underneath your workspace. And then you see I created other 2 SQL pools on here. So if I wanted to create a new one, when you click on this, for those familiar with SQL Data Warehouse, you'll see this looks similar to creating that database here. So I'm creating a pool with a database on there. So it's a one-to-one relationship with that. And here's that sliding DWUs that I can set on this. So once you create that, it takes a couple of minutes, and then you have your pool. And on here, you'll notice that I have the ability on here to pause and resume them, to scale them up or down As I mentioned before, those are manual operations. Many times customers will set some schedule to do that through a PowerShell script. And then the other one here is the Apache Spark pools on. And so if I go to here, you'll see I've created pools previously. When you click the new button on here, you'll get the node size that you can choose on here. So you see on this, I have these 3 different node sizes with different CPUs on there. So every node that's created in Spark will have this particular setting on there. I have the ability to set auto scale on, so you can see I can go to a min and max of nodes. Each of those nodes will have those characteristics. And under additional settings, you'll see I have the auto pause feature that I've set, in this case, to 15 minutes. So after 15 minutes of no activity, that this cluster will shut down. So the trade-off then is to start it back up. It usually takes 4 to 5 minutes. And I can choose to turn off the auto pause to have it running the whole time. And what most customers will do is they'll have a number of Spark pools set. So I can say I have a large one. It can do a lot because of the vCores that are set to it, and I give a certain amount of people access to that. So maybe your data scientist will have the access to a large pool, or your data loading jobs, and then other people who have queries that are not as important if they run, or notebooks, if they run quickly, will be attached to a medium or small. So this is sort of a between a SQL pool idea of pre-provisioning stuff and a pay-per query, which is the SQL on demand. This is sort of in the middle because it's sort of a pay-per cluster. You're starting up a cluster, you're paying when that cluster is running. So it's not a pay-per query. You can run as many queries and do as many things with the Spark processing during that time, and you're just paying this fixed fee on there. So there's a lot of things to think about when you go to the cost of how you want to set this all up. All right. So once we configure our pools up here, if we go to overview on here, you'll see we have this open Synapse Studio. And if I click on that, it's going to go to the Azure Synapse Studio workspace that I mentioned before. So this is your one-stop shop place to do everything. And you'll see we have these hubs that we'll jump to later. And then on the home screen, we have this ingest. So if I click on this, this is the first thing you usually want to do is I need to ingest data. And what happens is it opens up a copy data tool, a wizard, to pull data from some source system to some destination. So if I go here and I look at the connection, these are connections I previously set up. If I want to create a new one, on here it shows all the different sources that I can connect to. And then I would choose one, and then I would enter the connection string information. And then if I pick one that I've already created here, where I can then filter on, say, a folder or a file that I want to only use as part of this connection. Many times this could be a SQL Server, and you choose a database, and then you configure all this, and then for the destination, you'll do the same thing. You'll say, where do you want to send it to? You enter the connection information, and you're done. Now, for those of you who've used Azure Data Factory, this is very familiar. It's the same code base underneath the covers. Once I do that, it will create a pipeline. So if I go under my integrate and I look under pipelines, and a pipeline I could previously created using a copied data wizard would show up here. So you'd have this one box, and everything I entered in that previous wizard screen would show us here as a source and a sink. In this example, I'm taking data from SAP HANA and I'm landing it into the data lake. Now, also what you can do is once you copy it over into a data lake, usually it's a raw data area, and then you want to clean the data and copy it back out to a clean layer in the data lake, or copy it to Synapse, the relational database on here. And that's where the data flow comes into play. So this is another task. You see there was a lot of different tasks on here that you can choose, and it's just dragging them on here. And if you double click on data flow, this is going to the mapping data flow feature. That's also part of Data Factory on here. So here you can do a lot with transforming this data, and you can do it all visually. So it's a very easy to use a tool. Anything I create here task-wise, you can see if I pop open this box and I can choose one of these options here like join, and then I get this nice pretty look on how this works. So they've made it very simple by entering the properties on here. So I wouldn't say it's no code, it's low code. And to show that, if I look on its last 5 years, here I'm aggregating the data and I'm filtering it. And if I go and jump into here, I get the visual builder in here. So this is where I can go and I have tons of different functions on here. And I can just go in here and use IntelliSense and populates this expression. So it makes it very easy to transform this data. And so in this case, I'm filtering it. I'm selecting columns. I'm deriving columns on here, combining them together. I'm aggregating the data and then finally put it into Synapse on here. Now behind the scenes, this is using JSON. And this JSON, once I execute this, so I can do it once to execute it, or I can run it on a scheduled basis. And what happens is that JSON code gets turned to Scala and it goes behind the scenes and it runs it on a Apache Spark cluster on there. And that's where it gets a lot of tremendous speed on there. So I like to think of it as you putting a nice, pretty interface over the Spark cluster that's running behind the scenes. Great. So this allows you to take data from any source system or many different source systems. You land it into a data lake in most cases. And the other thing you're going to want to do is for that data lake, the first thing previously you want to link it. So I can create that data lake outside of this environment in the portal in there, but then I want to link it to make sure I can to allow me to interface it within the Azure Synapse Studio. So if I go to manage here, you'll see I have this link services, and this is where I can go and link to a bunch of different source systems on here. So this link on here is set up. There's many that I can use here to link to use it in Data Factory, but so all those can be used in Data Factory, and a few of them can be used to get direct links on the data tab, which I'll show you. So I can link in here. In this case, I have Data Lake Storage Gen 2 linked in. I can link in Blob and Storage. Once I do that, if I go to Data and I go to Linked, this is where whatever I linked on that previous page will show up. So in this case, it could be Data Lake Storage, and I linked to one of the accounts right here. And this is where then it shows the containers underneath that, and then the folders and all the data. So this is where I'm going to get into showing you the really great feature of exploration that you can use with Synapse Studio combined with SQL On Demand. So I'm going to pull up a chart here that is going to show you all the options available. And this chart here has the idea being that there are 3 different ways of compute. So I have the provision pools, on-demand pools in Apache Spark. And then I have multiple storage, which I went through before. So we have all these 4: relational database, Gen 2, Spark Table, and Cosmos DB. So there are 12 possible combinations on here. And this table shows you what's available. And I'm going to go through some of these in the demo. So you can see what it can do and some caveats I'll go through this. And then the only 2 that we cannot do yet are SQL On Demand against the relational database and the provision in Cosmos DB. So this is coming later after the GA. But we got plenty of other options on here that I'll cover. And then also there's a number of different objects within Synapse that you can right click and do things with it. So there's 7 objects listed here, and then each of those objects have up to 3 different ways of seeing the data inside there. There's a preview, there's a new SQL select, and then there's a notebook on there. So I'll go through a handful of these too to get you a better idea of what's the art of the possible in Synapse. So the first one I'm going to look at is an on-demand pool that's going against Gen 2, and it's going to use Parquet files. So jumping over to that, back to the demo here, if I go and I look at this Parquet file, I want to look at this Parquet file. Now think of what it was like before to do this. I'd have to fire up create a Databricks cluster, fire it up. I would have to open up a notebook, a Spark notebook, and attach this storage to that notebook, and then I have to write some Spark SQL to look what's in that parquet. It's time consuming. There's a lot of complexities involved in attaching storage, and then it's costly. Now I can go to this parquet, I can right click it, I can click new SQL select, and I can do select top 100. And when I click run, you'll see over here this on demand is chosen by default. And the magic of this is this open row set. And this allows me to go and select a file. It pre-populated this out, this parquet file. And this then returns the results. Now this took a few extra seconds because this wasn't warmed up. If I run it again, it's going to go from the 16 seconds down to just a couple of seconds or 1 second. So it'll take anywhere from 2 to 20 seconds to warm up. And we've got it, Microsoft has got it down now, so the 95 percentile takes 2 seconds or less on. But once it's warmed up, usually it'll stay this way for 15, 30 minutes. So I now have the data from that parquet file, also because it inferred, it can look through the file and find out the metadata on there. And here you can see all the columns that it pulled out on there. So I don't have to do any work to specify the columns on there. And I also have a chart where I can go in here and I can start playing around with the chart and get some basic reporting done to evaluate that data. So in a matter of a couple of seconds, right-clicking it, I've been able to explore this data. And I can also go on here and use wildcards. So instead of having the parquet file, just one of them, if I go in here and put a wildcard in here, I can also go in here and say, I don't want just one file, I want all the files in that folder, and run that. And now it's going to go through and get all those parquet files on there. And so I can put any sort of wildcards I want in there, and just within a few seconds, I get the results of that. Since this is regular SQL, I can also then use where clauses or any compatible SQL on here, T-SQL on here. So I can say where city equals UK and run that, and now I'm filtering that. So amazingly quick and easy, only paying per query on there. I can also decide that I want to create a view on top of this. So I want to save this and use it in the future. So if I come back here and I just say create view, and I say, well, I'll call this Twitter view as, and let's get rid of the top statement here. And I'll call this test. And if I run this, what it's going to do is store this into what I first have to choose is test SQL on demand. So this is the database that I've created. So it's a SQL on demand database, but it doesn't have any data associated with it because it's on demand. So it's going to save this view, this metadata inside of this on demand use database. So now if I go back to workspace and I click on databases, you'll see this test SQL on demand. And if I go to views, you'll see I have this Twitter view test on here. I can go and select it, and now I'm using that view. So it's a way to put a semantic layer on top of the data sitting in a data lake. And this allows it to make it look like it's a relational database when it's not. The end user can think, well, I'm querying a view, it's on a relational database. Well, actually the data is stored in the data lake. So this is a really amazing feature. And as you'll see, it makes it very easy then to utilize this data in not just querying, but in things like Power BI. The next thing I want to do is show how you can use CSV file and show it how you can use it in Apache Spark Notebook, as well as just do a preview on that. So going back to this Data Lake Store Gen 2 under the custom CSV folder, I have a bunch of CSV files on here. And if I right click this and click preview, you'll see right away, boom, it pulls it up. There's the data, it has the headers in there, and we're good to go. If I go and right click this, I have an option called load to data frame. If I go here, what you'll see is we have a statement that it created first it created a Spark notebook on here, and you'll see we have just added this feature to make it enhanced with this new notebook experience. And it takes the file that you want to query and populates it in here. And then if I simply choose the pool that I want to use to run this and click run, it's going to right away allow me to start kickstarting a Spark notebook on here by having this pull this data from this file and then display it. Now, for the sake of time, I went and did this previously where I created the same statement, I ran it, and this is what it looks like. And so the first time, as I mentioned, it'll take 4 or 5 minutes to start the Spark pull, and then afterwards it'll be warmed up, and all the Spark statements after that will take just a few seconds on here. You'll notice this configure session at the bottom here. If I click on this, this allows me to configure the session I'm using in this notebook, and I can go and change things. I can choose what I want to, which pool I want to use, and then how many executors and how I want to time out and such on there. So that's a really awesome feature that allows you to get a data in a file in a data lake. And again, you can use wildcard characters. So I can say all the files that are CSV, and I want to pull them into a Spark notebook. Next, what I want to do is show you how I can go to a SQL pool, a relational database, and then query that. So going back to workspace here, you'll see I have the SQL pool. And if I open this up, this looks just like the SQL Data Warehouse previously, where I have all my tables underneath there. So if I go to a large fact table here called SQL Sales, DBO Sales, and I do a new SQL script. So this is familiar for those who used SQL Data Warehouse before. Right away, I get a query. How the difference is, I now have this chart, so I can go and create a quick and easy chart to see what the data is on there. And this pool is where I choose. If I have multiple pools and multiple databases, I can just go and select them on there. Now, say I wanted to take that relational data, but I wanted to show it in an Apache Spark notebook. I can do that very easily too. If I go to another table, in this case, country, and I right-click it, and I go to New Notebook, there you'll see this loaded data frame. So this is going to open up Apache Spark Notebook. You'll notice that there's different languages I can choose from in here. And I then choose the pool, and I can run it. And so this data that's sitting in this relational database is now going to be loaded into a data frame in Apache Spark. And for the sake of time, I did this previously because it took a few minutes to start this Spark notebook up in here, and here you see the results. So very quickly, easily, right-click, get the relational database either just in a regular SQL format outputted or into a Spark notebook. Now, if I wanted to take data sitting in Data Lake Storage Gen 2 and query it from a relational database, can I do that? And yes, you can via the external table. So let me show you that. If I go to my linked account and I go back to the Twitter data on here, and I can go and choose a Parquet file. And if I right click this, you'll see this create external table command. And if I click on that, you will see it gives me all the parameters to enter to create that external table. So I can pick the SQL pool, the relational database on here, and the database I want to put it in, and then the table name. And then what will happen is this will automatically create a external table. So if I go to the workspace, I've done this previously, I look under pool and I go to external tables, you'll see I created that external table. If I go and select on that, it's now going and pulling that data from that file sitting in the data lake store too. So you can use this query and you can combine it with other queries that are going against relational databases to get data from both the relational and the data lake store Gen 2. Now I mentioned earlier that you can create a Spark table, and I can use that in SQL on demand. And the way that works is if I go to my develop here and I pull up a notebook that I've created previously, this Spark table example. Let me pull up this one. And so what you see here is I'm creating a database called New York Taxi. So this is a Spark database. And you notice up here, it tells you where it's storing that. So this was the pre-provisioned data lake store Gen 2 that I mentioned that you choose when you create the workspace. So it puts it in here. So a Spark table is really nothing more than a file within the data lake store Gen 2. And then I create a table on here as a Parquet table. This is currently the only format that allows you to use this table within SQL On Demand. And so I insert some values and I select from it, and then I can easily run from that. So run that. So that's all done through Spark. So now if I go into the data and the workspace here, and you will see I have this New York Taxi on here. So once I create it in the other one, it automatically creates the metadata in the on SQL On Demand. And if you go under tables, you'll see that test table that I created. And if I select it there, now I'm using SQL On Demand to pull data that was created and stored with a Spark table on there. And if I wanted to see that Spark table back in Spark, I can just right-click this, hit New Notebook, and load the data frame, and it creates the code for me to go and pull that data inside a Spark notebook. Now, the last query option I wanted to show you is the Cosmos DB one. So I can go back to data and then linked, and you'll see I have Cosmos DB that I went to that managed and previously linked to. And then that shows you the various sources I can query that are sitting in Cosmos DB. So with the vehicle data, I can right-click this, go new SQL, new notebook, and I can go load the data frame, and that will load the Cosmos DB data into a Synapse notebook. I can also right-click it and do new SQL script and do select top 100, and that will query the data in Cosmos DB using regular T-SQL, the SQL On Demand. And you just got to populate the key here that you get from Cosmos DB, and I did that previously and ran it here, and you can see it pulled back the data sitting in that Cosmos DB storage on there using regular T-SQL. And again, I can start using where clauses and all that inside of here to get all that flexibility. A question I hear a lot is, does this support Delta Lake and the common data model? And the answer is yes, it supports both. It's limited right now. With Delta Lake, it can query that using Apache Spark Pool, and then very soon with SQL On Demand. And with common data model, it can query same thing with the Spark notebook, and then pretty soon with SQL On Demand. So those options are available for you and can be integrated just similar to the way other things are. You'd access them the exact same way. Now I'm going to show you how to query 30 billion rows. So if we pull up this syntax and run it here, this is going to that sales table we had before and showing you that it's indeed got nearly 30 billion rows in it. And if I run this query here, which is pulling data from sales as well as 4 other tables and joining them all together with a group by and a where clause on here, there was no tricks. I didn't run this previously, and it took just 3 seconds. If I run it again, it's going to cache it. It maybe takes 2 seconds on there, but this is a statement that would probably take minutes, many minutes with this SMP version. Now here, it's nothing to run it in Synapse, and this is the power of the MPP technology. Now I wanted to show you this copy statement. So if I go to SQL scripts and I go to this external table, I'm just going to run through this. This is going to become popular as a way to import data. So instead of using Azure Data Factory, you can just do it directly through SQL, or Azure Data Factory will use this copy technology on here. So you can see this copy into statement that I've created right here. This goes and it takes data from this Twitter file, and I put in the credentials here, and it's going to copy it. This copy into is going to copy it into a Twitter account that I've created previously here, a relational database on here. So this is all you need to do. So there's no other setting up of multiple statements, which you sometimes had to do with external tables in Polybase now. The copy statement, think of it as an enhancement to Polybase, and it's a lot faster on there. So customers can use this just like this with an SSMS, or like I said, with an Azure Data Factory and any other tool that supports T-SQL. I want to show you a little bit about Spark Notebooks, what else you can do with that. If I go into Integrate and I go to Pipelines here and I choose up this marketing one, you'll see in here that I have this notebook task on here. And within the settings, I can go and click Open. And what this does is allows me to use Azure Data Factory, the pipeline option in here, to call this notebook on here. And if I open this up, you'll see here's the notebook and when it ran previously, what the output was on here. And so this is something that's basic. I can do a lot more sophisticated things. If I go into my develop and I go to a notebook here, you can see an example of product recommendations where I'm open up these libraries and I pull in data from a CSV file here, and then I'm going and running and training a model with that data, and then running that model and getting this, in this case, similarity of products on there, so to recommend other products based on what you purchase, and then I'm running the results out back to the data lake in the CSV file. So anything you can do Apache Spark, you can do within this notebook here. And the benefit is how easy it connects with any of your data sources. The other thing that's integrated into Synapse is Power BI. So to see that, I would have gone to the manage table before, and if I go to link service, you'll see I have underneath here where I previously connected to Power BI. This is a workspace I created outside of Synapse, as now can use it within Synapse. So if I go to Develop tab, you'll see I have under Power BI the option, or the workspace that I was connected to, so I can see the Power BI data sets that are pulled from this workspace. And if I open the Power BI reports, I click on one of these, you'll see this is now opening up the Power BI service and one of the reports, and then I can go and interact with the reports. And anything I do here, create here, will be outside the Power BI workspace. So you can see I am now able to go and use Data Factory to import data. I can run various tools, T-SQL, Spark Notebooks to clean the data. And then I can also use Power BI within this to go and visualize the data that I've created. You can also go, and if I go to the data sets here, if you say, well, I want to not use Power BI service to build the reports, I want to do something in Power BI desktop. If you go to this option right here, Power BI datasets, and click New Power BI dataset, it'll create a Power BI dataset for linking to some of the data that you've already created in here. So I can say I want to use a Power BI create a Power BI dataset based on the SQL on demand data source. And what this will do is create the connection information in a PBIDS file that allows me to click on this and open it right up within desktop. And because it has a little connection information on here, makes it one step easier to now create a report from that. And you'll see as it pops up, it gives me everything underneath that SQL on-prem database on here. And before we had like the Twitter view test, so I can click on that and click load. And now it's going to take that data. I can either import or use direct query, and it's going to pull that right in. So seems like a relational database is using. It's actually just a file sitting on Data Lake Store Gen 2. And I'm only paying for when this query is run. So it makes it very easy, and it also has a lot of cost savings involved on this. And then you can see right here, this is the data that was pulled in from that view. And I can go and start building out a report off of that. Many customers want to continue using SSMS, and that is still available in here. And so if you don't want to use the Synapse Studio or wanted to use SSMS for other things, if I go back to my workspace here in Overview, you'll notice here these SQL endpoints. There's on-demand and the regular endpoint on here. I can take those connection string information essentially, and I go to SSMS and I can create a connection to it. And here I've done that previously. You can see I've connected to the on-demand and the provisioned. And then if I open this up, I can just go through this and I can go and say, well, I want to look at this table that's actually a Spark table that I've created. and go through the view that was underneath there. Oh, sorry, let me go to the test SQL on demand and the Twitter view I created and do the select top 100 in there. So I can continue to use this. Not every feature in SSMS is in the Synapse Studio yet. So that's why I still see some customers that like SSMS because of the additional features that are available to it. So, and then any third-party tool that uses T-SQL can interface with this. So if you want to use SSDT or Visual Studio Code, all those will still work. So part of those third-party tools could be some monitoring tool that you wanted to use. So those can continue to be used against this. However, there are some built-in monitoring tools within Synapse already on there. So if I go to the portal and go to monitor, you will see I have under SQL requests here where I can go, and they don't have on demand yet, but they do have for the provision pool. So you can go and I can click on this, click on the ID, and I can get some information about what that query plan was that was used to that. Also going to Apache Spark and any of the query plans, I can go and click on here and view those that were done in Apache Spark and get more details on those. And this goes out to the actual Spark server on here and pulls up that data. So this is the only time you jump outside of that is to monitor some of the Spark jobs on here. And I can go back here and on the pipeline runs, I can see all the data factory pipelines that I ran and go and evaluate them too. Another feature that is a lot of people are not familiar with is the samples within Synapse. So if I go to data and I click on this plus button here, you'll see this browse samples. So now you have all these options, data sets. I can just in a couple of clicks, I can have full data sets that I can incorporate into my workspace in there for just for training and learning in there, or I can actually use some of this because it's real data. Like COVID is a popular one now, New York Taxi that's been around forever. I can go to notebooks and I can see a bunch of notebooks samples that I can use. For example, if I wanted to use Delta Lake, there's some information in this notebook that you can use. So it's another way to get kick-started in building a solution. There's also SQL scripts, same thing idea. There's all this code that you can use. You'll even see things in here like the ability to not only query JSON and Parquet files as samples, but how to use the copy permissions properly, how to use dynamic data masking, how to create external tables. So it's a great way to not reinvent the wheel and see how somebody else has done something. And then finally, pipelines. These are like data factory templates. So this is a great way to go and start off a Azure Data Factory job with somebody who's already done something similar. So for example, I have this copy data from Oracle to Synapse on there, so I can go and see how that's done. One of my favorites on here is the slowly changing dimensions. So it can go and show me how to do that within Source Data Factory. So definitely check those out as a great learning tool. And I wanted to end this with the federated query that I told you about earlier. This is a great feature within Synapse that's really come together now with the latest features they've added into it. So going back to the portal and going to develop and under the SQL scripts, I have this federated query 2 one. So taking a look at this, what I have here is a query off of the Data Lake Store Gen 2 using the open row set. And I also have a query of the Spark table on there. And these are saved as views. So I'm showing you them outside of the view, but it's simply just adding a create view on top of these. And then the third one is going against the Cosmos table on there. So I have 3 views that I've created. And what then I do is join all those views together. So this statement right here is taking the Spark table, the Data Lake Store Gen 2 file in there, and a Cosmos DB, and joining them all together. And in this case, it's just Twitter data, that's in the Data Lake Store Gen 2 table, and it's combining the query with data with the tables in Cosmos DB that are essentially reference tables to say if Twitter data should be showed up or not, because you can ban a city or you can ban a user on there and not show in the Twitter feed on there. So this took 4 seconds. This is going against 3 different data sources. So it's a really amazing technology. And if after I create these views, which is under the SQL on demand and then the test SQL on demand and the test SQL database on there. So if I go and show those back to data under SQL on demand, you'll see I have those views created on here. So I can then have this view in Power BI. And I run that view, and it's pulling the data from these 3 sources. It's leaving the data where they sit. It actually pushes down the queries. So in the case of Cosmos DB, it's pushing down the queries using Cosmos DB resources, returning back just the results into your Power BI, which will take just 3 or 4 seconds. And so you reduce the complexity of having to create ETL, and you're only paying when the queries run. So nothing to pre-provision. So really awesome feature, and this is only going to get better as more sources are available, that they're making them more available to query this data outside of Synapse. All right, so that is my time. I hope you enjoyed learning about Synapse and the demo. And this is information if you would like to contact me with any follow-up questions. A lot of what I talked about is on my blog, so you can go and get a little more deeper information. And then I'll now spend the next 15 minutes answering your questions. So thanks so much for attending.